video, we're going to talk about reference angles and then how we use reference angles to find trig ratios of angles that aren't specifically acute angles, but trig angles in standard position. Now, first of all, the reference angle. A reference angle is if you're given an angle theta in standard position. So remember, that's coming off of the positive x-axis, up and around for a positive angle, down and around for a negative angle, and you look at the quadrant that the terminal side is in. And it's reference angle theta prime, so whatever the name of that angle is, you're going to put a tick on the name for the reference angle, is the acute angle. So remember, acute angles are measures of angles that are between 0 and 90 degrees. For degree measurements. If you're looking for angle measurements in radians, it would be an angle between 0 and pi over 2. Formed by the terminal side of theta and the nearest x-axis. So it's very important that you always go to the nearest x-axis with this. Now, how we're going to use this when we get to the trig functions of angles is to evaluate the trig function of theta. Find the trig function of theta prime, the trig function of the reference angle, and then use the appropriate sign, the appropriate plus or minusness for what that trig ratio should be, depending on what quadrant the angle is in, for the trig function in the angles quadrant. So first of all, what we're going to do is practice finding the reference angle. And then after we get the information about practicing the reference angle, we're going to go and then utilize the idea of the reference angle to how we find trig functions of angles. So first, find the reference angle for. So notice, this isn't a trig function acting on an angle, it's just an angle itself. Now for part A, if I have an angle that's 143 degrees, I think, okay, if I went, it's positive. So from the positive x-axis, we're going up and around. 143 degrees is somewhere between 90 degrees and 180 degrees. So 143 degrees going up and around is going to take me into the second quadrant for my 143 degree. Now the reference angle we're supposed to find is the angle formed by the terminal side of theta and the nearest x-axis. Well, this terminal side of theta and the nearest x-axis is right in here. So that's your theta prime for that particular one. And then you want to think, well, how would I figure out what that angle is? Well, 143 degrees is just shy of 180 by whatever that theta prime is. So when you have an angle that on the first rotation around, it ends in the second quadrant, you're going to take 180 minus that angle to get what the reference angle is. So here we have 180 degrees minus the 143 degrees is going to give me 37 degrees. So the reference angle for a 143 degree angle is 37 degrees. Okay, so now let's look at the next one. So go ahead and take that angle off and look at what we have for 191 degrees. So again, it's a positive angle. 191 degrees is past the 180, but not quite to 270 yet. So if I go 191 degrees, it's past the 180, but not to 270. So there's my 191 degrees. And going to the nearest x-axis is right here. So this is my theta prime. Now in this case, because the reference or the original angle's terminal side is in the third quadrant, it went beyond the x-axis, that's the closest one that I would go back to. I need to take the angle measurement minus the 180 to get what that reference angle is. So my 191 degrees minus the 180 degrees is going to give me 11 degrees. So my reference angle for that one is 11 degrees. right, how about 310 degrees? Well, again, it's a positive angle, so we're going to go up and around. And 310 degrees is beyond 270 degrees, but not quite to 360. So for 310 degrees, we're going to pass the 90, pass the 180, pass the 270, and get to about right there. My theta prime is to the nearest x-axis. So if this is my 310 degrees, then to find that angle that's to the nearest x-axis here, it's whatever the rest of the way would have been to get to the 360. So we're going to take 360 degrees minus the 310 degrees to get our reference angle. And we see that that is 50 degrees. Now also remember that our reference angles are acute angles. So they are angles between 0 and 90 degrees, or 0 and pi over 2. 37 degrees, 11 degrees, 50 degrees, they all meet that requirement. Okay, how about for part D? It's negative 15 degrees. So then when we're doing the work with my negative angle, we are going to go down and around. So negative 15 degrees is that angle in standard position. Well, going to the nearest x-axis is the same opening. It's just that your reference angle is always just that measurement that is to the nearest x-axis, and it's acute. So I'm going to have a reference angle of 15 degrees. Now let's try some that are in radian measure. So next up is a negative pi over 6. So I'm going down and around 1/6 of a pi. So down pi over 6 for my theta. And then the reference angle again is to the nearest x-axis, but it's the acute angle there. So here my reference angle will be pi over 6. How about for 4 pi over 3? Well, for 4 pi over 3, we want to remember that from 0 all the way around is 2 pi. From 0 to halfway around is pi. 4 pi over 3 is pi and 1/3 of a pi. So you kind of want to think of it as fractions, fractional values of your pi. So 4/3 of a pi is pi plus 1/3. So when I do 1/3, 2/3, 3/3, 4/3, my 4 pi over 3 original angle theta is going to land in the 3rd quadrant. Now remember, if I'm landing in the 3rd quadrant, very similar to when we had the 191 degrees, that's beyond the x-axis, so you got to subtract off this 180 degrees if you're in degree measurements, but if you're in radian measurements, you're going to subtract off pi. So we have 4 pi over 3 minus pi, and then the 4 pi over 3 minus pi just gives me pi over 3. So my reference angle here is pi over 3. Remember, to the nearest x-axis. Okay, how about for part G? 3 pi over 5. Well, when I'm looking at my radian measurement angles, 3 pi over 5, it's not quite to pi. I just have to decide on what side of pi over 2 it's on to know whether it's in the 1st quadrant or whether it's in the 2nd quadrant. Well, 3/5 is bigger than a half. So 3 pi over 5 is bigger than pi over 2. So 3 pi over 5 is actually landing in my second quadrant. So when I look at the second quadrant angle there with the 3 pi over 5, then theta prime reference angle is to the nearest x-axis. Now 3 pi over 5 is shy the reference angle from going all the way to pi. So we will take pi and subtract the 3 pi over 5. Get common denominators of 5, so that's 5 pi over 5 minus 3 pi over 5, which is 2 pi over 5. So the reference angle for angle of 3 pi over 5 is 2 pi over 5. So I hope that's helped you with the reference angles. The next thing is, let's use the idea with the reference angles to find trig functions of angles that are outside of the first quadrant. So what we're going to do is we're first going to think of the angle. So 135 degrees is more than 90 degrees, but not quite to 180. So that is a second quadrant angle. I want to find the reference angle. Since it's in the second quadrant, my reference angle goes to the nearest x-axis, which is the negative x-axis here, and it's not quite to 180. So to figure out what this leftover is, or what this value is, I need to take 180 degrees and subtract the 135, and that'll tell me the reference angle. Well, 180 minus the 135 is 45 degrees. So I can think of the cosine of 45 degrees to get started, but I also have to think about the plus or minus this that I need. Now, it's the cosine of 45 degrees, or it's negative the cosine of 45 degrees, depending on what sign the cosine should have in the second quadrant. Well, if you remember back to our basic definition of the trig ratios, the cosine of an angle's ratio is the x-coordinate over r. And to get to the second quadrant, you have to go left. For your x value will be negative then, and r is always positive. So the cosine of angles that land in the second quadrant are going to be negative ratios because it's the x-coordinate divided by r, so it's going to share the sign of the x-coordinate. So we're going to need a negative cosine of 45 degrees. Now 45 degrees is one of our nice angles, and the cosine of 45 degrees, you'll remember, is the square root of 2 over 2. And because it's in the second quadrant, our ratio is going to be negative the square root of 2 over 2. Okay, let's do the next one. The sine of 150 degrees. Sorry, the sine of negative 150 degrees. So I'm going to go down and around 150 degrees. So down 90 degrees would take me here. And then negative 150 degrees is somewhere in the third quadrant. So it's past negative 90, but not quite to negative 180. So I have my theta being my negative 150 degrees. The reference angle, theta prime, is the angle, the acute angle to the nearest x-axis, so that's here. And so when we think about what that would mean is that I'm not quite to the 180, and in negative 180, and in fact I'm 30 degrees shy of that. So my reference angle, theta prime, is 30 degrees. And remember, your reference angles are always going to be between 0 and 90 or between 0 and pi over 2. They're never going to have a minus sign on them for reference angles. So this is going to be the same as the sine of 30 degrees. And then also take into account whether it needs to be plus or minus that. Well, for the sine ratio, it is the y coordinate over r. R is always positive, so the sine ratio will have the exact same plus or minusness that the y coordinate has. So to get to the third quadrant, you have to go left and down. So the y coordinate would be, the down part would be negative. So we're going to have a negative the sine of 30 degrees. 30 degrees again is one of our nice angles. The sine of 30 degrees is a half, so this will be negative 1/2. Last one, the tangent of negative 3 pi over 4. So when we think about our work with going negative 3 pi over 4, negative, I'm going to go down and around, and I'm going to go 1/4, 2/4, 3/4. So my negative 3 pi over 4 is here. The nearest x-axis is where I draw my reference angle theta prime. And for theta prime, that is just a pi over 4 shy of being that halfway around. So this is going to be the same as the tangent of pi over 4, and then I still have to think about the plus or minusness of tangent in the third quadrant. Well, remember, tangent is the y coordinate divided by the x coordinate. So I have to think, what would the overall sine of taking the sine of the y coordinate divided by the sine of the x coordinate? Well, to get to the third quadrant, we have to go left, which is negative for the x coordinate, and down, which is negative for the y coordinate. So the negative for the y coordinate divided by the negative for the x coordinate, negative divided by negative is overall positive. So it actually is going to be the same as the tangent of pi over 4. And the tangent of pi over 4, you can think of a couple ways. One way is to think, well, sine of, or tangent of an angle is the sine of the angle divided by the cosine of the angle. So sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is also square root of 2 over 2. So when I take a non-zero number and divide it by itself, I get the number 1. So tangent of pi over 4 is 1. So that gives you some examples of how to find reference angles, and then how to use the idea of the reference angles to find the trig functions of any angles through the use of